When talking about waves, sound waves, or any waves, principle of superposition is very important to understand. Waves passing through a medium displace the particles of the medium in their path, which is directly proportional to the amplitude of the wave. When the incoming waves meet at some point, the amplitude of waves are small. Then the particles in the medium are not too displaced, and the waves pass through each other and come out of the collision unchanged. If, however, the amplitude of the waves are large enough and the particles in the mediums are displaced far enough from their equilibrium position, the waves are said to interfere with one another. And we will talk about interference in a little bit. So let's talk about superposition. Superposition for incoming waves when the amplitudes are not too large can be formally stated as when two or more waves overlap, the net displacement at a point in a given medium is the linear sum of the individual disturbances due to each wave. For example, the sounds coming from a marching band that reach our ear is very complex. However, if we are very careful, we can pick out the sounds made by individual instruments. Mathematically, if two waves are passed through a single point in a medium, say air, at the same time, and the two waves are expressed as psi1 and psi2, then displacement at a molecule that the molecule of air feels due to the presence of these two waves will be given as a linear sum psi1 plus 2, where psi is just equal to psi1 plus psi2, where psi1 was the one wave and psi2 was the other wave. It is interesting to note that the waves will pass through each other and emerge on the other side of this interaction nearly unchanged. This allows us to distinguish two people speaking in a room at the same time, since the sound waves pass through each other nearly unaffected. So when we talk about superposition of sound waves, incoming waves with different frequencies, different shapes come together from, as seen in this animation from the top. They come together, they sum up. It's purely mathematically, arithmetically. So for example, if the amplitude of one wave is 2 and the amplitude of the other wave is 4, the sum will actually have an amplitude of 6. And then these both waves will go away from each other, maintaining whatever they brought in terms of their shapes and their amplitude and all of their properties. Some important aspects of superposition are each wave maintains its own identity and is unaffected by the other waves in the same space. This is why you can pick out individual conversations among all the voices in the region of your ears. When two or more waves are in the same medium, the overall amplitude at any point on the medium is simply the sum of the individual wave amplitudes at that point. And it's literally just the sum of the individual amplitudes. Just 1 plus 1 equals 2. Talking about interference of a wave. So in order to talk about interference of waves, we need to talk about phases of a wave. So there are two waves that are incoming, can either be in phase or out of phase. When they are in phase, you can see that each wave pretty much follows the same pattern. The crests line up and the troughs line up and all the other wave particles line up. If the other way, on the other hand, if the waves do not line up properly, where the crests are not quite matching up and the troughs are not quite matching up, those two waves are called out of phase. Another important definition are called coherent and incoherent waves. Coherent waves are those waves in which they have the same frequency and the same phase. Waves are called incoherent waves when different waves that are coming in have the same frequency, however, that there is a phase difference between the two incoming waves. Reality is, coherent and incoherent are idealized scenarios. In reality, it's almost impossible for two waves from different sources to have perfect phase correlation. Here is a very good animation to see interference patterns. So as you see, the two spots right down here are moving closer and further away from each other. And as they move closer and further away from each other, the patterns that they are forming are varying. So very soon you'll be able to see the animations going in and animations going out. And this is called interference. They actually impact, due to the interference pattern, they actually impact the other waves that are in their vicinities. And this is also, if you wanted to see what the interference patterns look like. When different waves collide, they interfere with each other. This is called wave interference. There are different kinds of interference. In the first case, there's going to be constructive interference. Two waves which are exactly in phase will add together to produce a stronger wave. When this condition happens, we call it constructive interference. When two waves which are exactly inverted or 180 degrees out of phase cancel each other out and produce complete silence. This is called destructive interference. Destructive interference is very important in noise cancellation headphones. Intermediate are those sound waves which have varying phase relationships and they produce differing sound effects. Basically what that means is at some places they will be constructively interfering and in other places they will be destructively interfering. Here's another very good example of wave interferences. So there are two waves, one in green and one in blue. So one wave is stationary just to show how the interference pattern works, and the other wave is actually moving, the blue one. And the black actually shows you the interferences at different points. So when you see that the two waves, the blue and the green, are in phase like there, it's constructive interference. And when they are completely out of phase, it is destructive interference. And everywhere in the middle, it kind of has some places of constructive and some places of destructive interference. And this is how interference works. The idea of interference is exceptionally important in music. Musical sounds are all often constant frequencies held for a sustained period of time. Sound waves interfere in the same way as other waves do. However, when sound waves are musical sound, the resulting superposition can either be pleasant or it could be unpleasant. So musical scales that consist of notes which are when played together should sound pleasant to us. Okay? But this is why interference in music becomes very important. There are, however, disadvantages of destructive interference. For example, noise cancellation is used in audio headsets especially in order to reduce the background noise that is always present in our surrounding.